Hello again. In drug formulations and preparations, there is an important part and a critical attribute of a drug, which is its pH level. You already learned the basics of what is a pH and what is a pH meter. We also learned a little about its significance for drug stability and absorption to the human body. We already discussed in pH training that we are going to prepare a buffer solution to maintain the pH level of a drug. Let's understand more about what a buffer solution is and how a buffer can control a pH of drug formulation during manufacturing. It acts like a shock absorber. Buffer provides stability of a solution in case of pH level changes. Buffer absorbs the shocks of pH change. Buffer solutions are used for a wide range of chemical applications. Let's use the example of blood. There is natural capability within your blood which works as a buffer. Let me give you more insight to make it more understandable. Blood is one example of a buffer-like capability found naturally in humans, which can keep the pH level stable under all conditions. Let's understand that. Blood has a natural pH of 7.4. But we as humans at times experience severe anxiety and go under stress conditions. Certain types of strains and stress on the body can cause a condition called alkalosis. Alkalosis is a condition in which blood pH level turns excessively high due to stress, but there is a natural capability within your blood. This natural capability allows the chemical present in the blood to maintain and keep the pH to its own level of 7.4 and does not let it fluctuate, regardless of actual alkalinity being increased or decreased in the blood for that matter. The reverse condition is called acidosis. In that case, blood pH level decreases to the acidic side, which means it may fall below 7 towards lower number. So, your natural pH level could be a lot less than required for you to survive or stay healthy. This natural phenomenon, or the buffer-like capability of blood, keeps you healthy all the time regardless of the changes behind the scene in your body. Similarly, a buffer solution used for a drug ensures that if for any reason during the manufacturing to the life of drug before its expiration, pH of the drug would be stable. This science is already established and now you just need to follow how to prepare a buffer, how to check a reading, how to adjust and operate a pH meter. That's all. Let's understand the importance of pH in more depth and significance of its levels on human life in general for better understanding. Some chemical reactions only occur at a certain pH levels in different organic or chemical substances. Let's take examples of households and consumer items to understand their pH values and how these chemicals would react differently if the pH was lower or higher. For an instance, for a shampoo to combat the soap's alkalinity to avoid inflammation of your scalp, which can cause dandruff in your scalp. To control this, right pH level of the shampoo should be between 5 to 7, depending on what kind of other chemicals are used for formulation of this shampoo. A certain chemical buffer that is more compatible, keeping recipe of the shampoo in mind has already been established by the shampoo manufacturer. Let's take another example of a baby lotion. A baby lotion should retain a pH of around 6 to discourage multiplication of bacteria on kids' skin. This is another way of understanding why pH levels are important. Washing powder, eye drops, fizzy lemonade drinks, there are hundreds of examples available online for several general products that we consume every day and their pH levels are important to humans. pH level makes significant change in bioavailability of drugs or food products for humans. Buffer preparation and its use is vital in drug manufacturing. The drug's pH level should be most compatible with your blood, for your body to absorb the drug in most benefiting way. This is all you need to know about a chemical that you would be preparing at your manufacturing facility. Your company has already figured out the most compatible buffer chemical composition, which starting chemicals to use, and how to prepare a buffer. All those instructions are predetermined and written in work instructions. These instructions are part of your training as a manufacturing technician. You will be trained by the company on how to prepare the buffer before executing any buffer preparation activities. Now you have a complete understanding of what a buffer is, and why are buffers used, and how to prepare. Check the reading of the pH in a solution and moreover adjust it if needed to reach a desired level. Now we understand that buffer is a chemical mixture with a certain pH, and there is a requirement for the drug to take it to a certain level. In your BPR, there are step-by-step directions on which certain chemicals to take, how to check their reading first, and adjust the pH if needed. And these adjustments are made by two chemicals. Let's understand that. One chemical is HCl, which is hydrochloric acid. This is strong acid. If you need to take the pH to lower numbers below 7, your BPR would suggest to add HCl with small increments of 0.5 ml in order to reach the desired level. On the other hand, if you need to make that more alkaline, there is a chemical called NaOH, which is sodium hydroxide, to take it to the higher numbers of pH 8 and above. pH level of the drug being manufactured can change when during the process a new chemical is added. This new chemical being introduced to manufacturing mix could introduce higher or lower pH level, as every chemical has its own set pH level. The buffer solution present in the manufacturing mix is actually preventing pH changes of manufacturing mix and keeping it stable when a new chemical is added, just like your blood's capability we discussed. That's all. Now you know how to prepare buffer from scratch. The great news is most companies nowadays use prepared buffers that need minimal adjustment. These are two types of buffer, an acid buffer and a base buffer. Acid buffer is used where acidic pH is desired and it resists pH to go on alkaline side upon addition of strong alkaline solution. For base buffer, this buffer is used where alkaline pH is desired and it resists pH from dropping down to the acidic side upon addition of acidic solution or a chemical which is being added that could have more acidic pH. The BPR steps will give you directions on which chemicals to gather first and how to mix these chemicals to get to the final desired buffer. And record the pH reading into BPR with your initials and date. Moreover, attach the raw data printed from pH meter to BPR and the log. This is your responsibility as a manufacturing technician. As a rule of thumb, follow BPR steps as written and write what you have done. Thank you for being with us. See you in the next training.